Hello Colonel Africa online students, welcome to our second lesson on this topic of salts. In today's lesson we shall look at the solubility of salts in water. We shall further look at the solubility of bases in water. So in this experiment 4.1 we are going to see whether or which salts are dissolved in water. In this procedure, label 4 test tube 1, 2, 3 and 4. I'll leave the 4 test tube in a test tube rack. Place about 5 centimeters cubed of water into each test tube. Add about a spatula full of sodium sulfate, sodium chloride, sodium nitrate, and sodium carbonate in test tube 1, test tube 2, test tube 3, and test tube 4 respectively. Shake the mixture. If the salt appear not to dissolve, warm the mixture. Record the observation as shown in table 4.1. This is our table 4.1. We have the anions and the cations. The anions are negatively charged ions, the carbonate, the nitrate, the chloride, the sulfate, and the cations are positively charged ions, that is the metals and ammonium. In this case, we have sodium, potassium, calcium, magnesium, and all the other metals that you're going to test. So you put a tick if the salt is soluble. In this case, we have sodium chloride is a soluble salt, and that's why you have a tick there. Then if it is not soluble, you put a cross. The carbonate of magnesium is not soluble, and that's why you have a cross there. If the salt is slightly soluble, you put a SS, and if it is also soluble in hot water, you put SH. An example is indicated in the table for sodium chloride and magnesium carbonate. As examples, we have shown that. Then repeat the experiment using similar salts of sodium, potassium, ammonium, magnesium, calcium, aluminium, zinc, iron, lead, copper, and barium. Let's look at the discussion. All potassium, sodium, and ammonium salts are soluble in water. All nitrates are soluble in water. All sulfates, except those of barium and lead, are soluble in water. Calcium sulfate is slightly soluble. All chlorides are soluble except lead 2 chloride and silver chloride. Lead 2 chloride is insoluble in cold water but soluble when hot. Lead 2 chloride is insoluble in cold water. It doesn't dissolve in cold water, but soluble. It dissolves when you heat it in water, in hot. All carbonates are insoluble except those of group 1 metals and ammonium. So you have to be careful with this experiment, because in form 4 you're gonna use the same concept when you come to qualitative analysis, whereby you carry out experiment to see whether in a given known what ions are present. Let's look at the discussion. This table summarizes the solubility of various salts in water. If you look at the sulfate, we see that all the sulfates are soluble except for lead and barium, and that's why you have next there and next there. Calcium, however, sulfate is slightly soluble, that's why you have an SS. If you look at the chlorides, all chlorides are soluble except for lead, and for the lead you have SH, which means it is not soluble in cold water, but it is soluble in hot water. It can only dissolve in hot water. Nitrates are all soluble. If you look at the carbonates, they are all insoluble except these 3: the sodium, potassium, and ammonium. All the other carbonates are insoluble. Aluminium carbonates do not exist. Iron carbonates do not exist. Then this summarizes the solubility All potassium, sodium, and ammonium salts are soluble in water. You can see in that table. Nitrates are all soluble. If you look at that table, you can see they all have thick. All are soluble except silver and lead to chloride. Lead to chloride is soluble in hot water. That's the chlorides. All sulfates are soluble except barium sulfate and lead to sulfate. However, calcium sulfate is slightly soluble, and that's why you look when you look at that table, you can see X at lead and X at barium, and S is slightly soluble with calcium. All carbonates are insoluble except potassium, sodium, and ammonium carbonate, which are actually soluble in water. And let's look at the solubility of bases in water. Some salts are produced or are products of chemical reaction between acids and bases through neutralization reactions. Knowledge about the solubility of bases is therefore useful in the formation of certain salts. Solubility of bases in water. Let's look at the experiment 4.2. It describes or shows how bases are dissolved in water. This is a procedure. Place about 10 centimeter cubic of water into a boiling tube. Put half a spatula full of calcium oxide in the boiling tube. Shake the mixture and test the dissolving solution with a litmus paper. Record the observation in the format shown in table 4.4. Repeat the experiment using oxides of magnesium, lead, zinc, aluminium, and copper. Repeat the experiment using the hydroxides of sodium, potassium, calcium, zinc, copper, and aluminium. Then note carefully that zinc, copper, and aluminium hydroxide can be prepared by precipitating the hydroxide by double decomposition. This is the summary of the solubility of the bases. These are the cations and the metals. So we have the oxide of potassium and the hydroxides. These are the metals and the oxide and the hydroxide. If you look at the solubility, you're going to see that the oxides and hydroxide of potassium and sodium are soluble. Those of calcium, magnesium, and barium, they are all slightly soluble, which means they don't dissolve fully. For zinc, aluminium, iron, and lead and copper, they do not dissolve at all. The oxides of these metals and the hydroxide of these metals do not dissolve in water. They are insoluble. If you look at the effect of dissolving solution on litmus paper or litmus solution, for it to have an effect on this litmus paper or litmus solution, it has to dissolve. If you have it dissolved, it has ions, that is the hydroxide ions, that can turn red litmus paper to blue, or red litmus solution to blue. And that's why for the potassium, sodium, calcium, magnesium, and barium, we have the litmus solution turning to blue, or litmus paper turning to blue, because we have the presence of the hydroxide ions that is responsible for that color change. For the others, because they don't dissolve, that means we don't have the ions or the hydroxide ions, then it means that it doesn't have any effect. The litmus solution will remain the same. The red litmus paper will remain the same. If you have red litmus paper, it will remain the same. If you have blue litmus paper, it will remain the same. And that brings us to the end of our second lesson on this topic of salts. So you have questions to talk on. Do the questions. Make sure that you do all the questions. And once you do all the questions, you have the answers provided in the Word document that is accompanying this video. All the best. Let's meet in our third lesson next time. Have a good one.